This is Lesson 4-4, Day 1, Families of Functions. You will need a sheet of notebook paper in addition to the graph handout sheet provided. In today's lesson, we're going to recognize families of functions, graph families of functions, and graph a constant and vertical line. First, on your handout sheet, find the linear function. We will complete the handout sheet for the parent function is f of x equals x. Notice here the independent variable x is raised to a power of 1. For the graph, sketch a line for the linear function. A linear equation makes a line. Now find absolute value function on your handout sheet. The parent function is f of x equals the absolute value of x. Notice this contains an algebraic expression within the absolute value symbol. Sketch the graph of an absolute value function. This makes a V shape. Absolute value equations make a V. Now find the quadratic function. The parent function is f of x equals x squared. Here, the independent variable is raised to a power of 2. The graph of this function makes a U shape. It's a continuous curved line that makes a U. Quadratic equations make a U shape. We will now look at example number 1. You'll need to copy this to your notebook paper. You have 8x minus 2y equals 24. We're going to solve each equation for y and then determine if each function is linear, quadratic, or absolute value. If none, we will write none. So to first solve for y, you'll need to subtract 8x from both sides. Notice 24 minus 8x, they are not like terms. We'll want to write this in slope-intercept form, so put the terms in descending order by the exponents. So negative 8x plus 24. To solve for y, we will now need to divide by negative 2. When you divide by negative 2, every term is divided by negative 2. So we have y equals 4x plus a negative 12, or you can just write y equals 4x minus 12. Look at your parent functions. This function has the independent variable x raised to a power of 1. There's an understood exponent of a 1 on that variable x. So this makes it a linear function. Example number 2. Copy this to your notebook paper. We have 2x to the fourth minus 3x plus y equals 7. In order to solve for y, we'll need to move the terms away from y. So do that by first subtracting 2x to the fourth. We have negative 3x plus y on the left. Put your terms in the correct order, so the negative 2x to the fourth will go first, and then plus 7. Now we'll add 3x to both sides. Notice we still have no like terms, so this term will just go in order after the negative 2x to the fourth. So when you solve this equation for y, you get negative 2x to the fourth plus 3x plus 7. Look at your parent functions. This has an exponent of a 4 on the independent variable. You will study these types of equations in Algebra 2. Therefore, we will just write none for our answer. Example number 3. We have 4x squared plus 2x minus 3 equals y. It may be helpful to rearrange the equation and put the y on the left-hand side. So we'll write it y equals 4x squared plus 2x minus 3. We can see in this problem the independent variable is raised to a power of 2. The 4x squared term makes this a quadratic function. Example number 4. Remember, you must solve the equation for y before determining what type of function it will be. Y minus 11 equals the absolute value of 9x minus 5. You'll need to solve for y by adding 11 to both sides. When you add 11 to a negative 5, you get a positive 6. So our equation is y equals the absolute value of 9x plus 6. This equation contains an algebraic expression within the absolute value symbols. So this is an absolute value equation, this is an absolute value function. We will now look at graphing families of functions. Example number 5, we will graph the function using the given domain. Copy the problem to your notebook paper. Notice on the back of the handout sheet, you will use the graphs provided to graph, but your work must be shown on notebook paper. First, pay attention to the parent function. This is a quadratic function. It's always helpful to realize the parent function, so when you start to graph it, you'll know what shape it should make. On your notebook paper, make a table of values using the domain for the x. We were given the x values negative 2 to 2. We will substitute these numbers into our function in order to solve for y. You must show this work on your notebook paper. Plugging in each x number into the equation. When you work out the equation, you can put your y value into the table of values. Continue working out each x number in the equation. You can use order of operation to simplify the equation. If you're not sure how to do that, you may use your calculator to punch in the equation. When we complete the table of values, we will begin plotting the points on our graph paper. When you plot your points, be very careful to notice this should make a U shape. Plotting each point from the table, we do realize this starts to make a U shape when we plot our points. When you connect these points, it makes a smooth curved line. Do not make it a V shape. This is a quadratic, so it should be a U shape with a smooth curved line. Notice my arrows at the end of my graph. You must have arrows on your graph as well. Example number 6. We have y equals 3 times the absolute value of x. We're going to use the domain -3, -1, 0, 1, and 3. This should be written on your notebook paper. First, notice the parent function. This will be an absolute value function. So when we graph it, it will make a V shape. Start with the table of values on your notebook paper, using the given domain as the x values. We will substitute the x into the equation. You must show this work on your notebook paper, plugging in each value for x. Use order of operations to simplify. If you're not sure how to do that, you may use your calculator to punch it in. Remember, the absolute value bars in your calculator can be found under Math, arrow to the right, select Num, and then it's the first option, ABS. When you complete your table of values, you can begin plotting your points on your graph paper. When you plot your points on your graph paper, notice whether or not it will make a V shape. If a point is not lining up, then go back and check your work for your table or how you've plotted your point on the graph. These points do make a V shape, so we will connect the dots with a smooth, straight line. It is best to use a ruler or some other short, straight edge in order to connect the dots. Again, we must have arrows at the end of each line. This graph does continue beyond these points, so include the arrows on your graph as well. Example number 7. We have f of x equals -4x. F of x is the same as y, so when we make our table of values, x column will be our domain, and the y column is the same as f of x. Notice the parent function. This will be a linear function. Using the domain for our x values, substitute each value into your equation to find the f of x, or the y value. Using order of operations, we multiply. Be very careful with a negative times a negative. That gives us a positive value. Continue to evaluate with each value of the x. As you complete your table, begin plotting the points on your graph paper. Notice I have skip count on the graph. Anytime you choose to skip count on your graph, you must show that on your x and y axis. If you do not skip count, then it is not required to label your axes. Plot your points on the graph paper for each value of x and y. Be very mindful as to where the values that don't show on the graph will be. For example, -312 will fall in between 10 and 15, but closer to 10. Once you plot all the points, you should notice this does form a line. Connect the dots with a smooth, straight line. It's best to use a straight edge like a ruler or another sheet of paper. Just like our other graphs, we'll need to include arrows at the end of each line. This line does continue beyond these points, so show that including arrows on your graph. We will now look at graphing constant functions and vertical lines. Flip back to the front of your handout sheet. Find the area that says constant function. The parent function of this graph is y equals k, where k is a constant. Be sure to write that in on the blank. K is a constant. The graph of a constant function is a horizontal line. We will set up tables of values like you see there on the left of the screen. Using the domain values -2 to 2, the y value is that k of the constant number, whatever that may be. Let's practice graphing these on our graph paper. Example number 8. We have y equals -6. Copy this to your notebook paper. Notice the parent function is y equals a constant, which will make a horizontal line. On your notebook paper, make a table of values. It says y equals -6. So in our table of value, every y must equal -6. On your notebook paper, I want you to write that you may choose any value for x. In your homework, you do not have to write this. It's for notes purposes only. Choose any value you would like to use for the x. I'm going to choose -5, -3, 0, 3, and 5. Many students choose -2 to 2 and use those as their domain values every time. Now graph this table on your graph paper. Notice as you're plotting your points, they will start forming a horizontal line. The horizontal line is at y equals -6. Example number 9. We're going to graph f of x equals 4. This is the parent function y equals a constant. Because remember, f of x is the same as y. So again, make a table of values where every y number, or in this case, f of x number, is 4. You get to pick your favorite numbers for x. Choose any value. This time I'm going to go with -2 to 2. So when you plot these points on your graph paper, be very careful to notice that this does make a horizontal line as we expect it to do so. Connect the points with a straight edge and put arrows on both ends. Let's look at our last type of graph, a vertical line. Again, on the front of your handout sheet, copy this information to your paper. Notice this graph is not a function. If we use the vertical line test, a vertical line would fail the vertical line test. In this equation, x equals k, and again, k is a constant. Be sure to fill that in on your handout sheet. So in this case, when we graph these on our graph paper, our lines will be a vertical line. Remember, in order to be a function, it must pass the vertical line test. A vertical line cannot pass a vertical line test. Let's look at these now. Number 10. On your notebook paper, write x equals 7. Again, notice the parent function is that x equals a constant number, so that will make a vertical line. You will need to make a graph by first completing a table of values. This says that x must equal 7, so make every x value in your table a 7. This is where you get to pick your own y values. Choose any number you would like for the y. Once you complete your table, begin plotting the points on your graph. As you plot your points, notice that it should make a vertical line. Connect the points with a straight edge, drawing arrows at both ends. Notice this graph is not a function. Each x can only be paired with one y in order to be a function. We have the same x paired with several different y's, so this is not a function. It fails the vertical line test. Example number 11. We have x equals -9. Again, this will be a vertical line because the parent function is x equals a constant. So make your table of values where every x is a -9. You get to pick your own y values. Here I change it up and go with -12, -6, 0, 6, and 12. You get to choose your own y values when graphing a vertical line. Plot these points on your graph paper. Notice because I chose to skip count on my graph, I labeled those numbers. You must do so anytime you want to skip count. This does make a vertical line as we expected it to do so. Connect the points with a straight edge and put arrows on each end. This concludes Lesson 4-4